In this episode, I've decided to delve into one of the most controversial topics of our time, GMOs. Join me on a journey to discover what it's all about. Is it good? Is it bad? Will it save the planet or kill us all? I'm Justin Harnish, and this is Off My Block. After many hours of watching documentaries, searching the internet, taking part in forums and Facebook conversations, I've found that the subject of GMOs can be a ferocious argument filled with opinions. For the most part, these opinions are fear-mongering and based on misinformation. Yes, I have formed an opinion about GMOs, but it's not to say I can't change my mind based on new information. I've heard many very good arguments for and against the use of GMOs, which has proved to be a bit of a minefield, because for every good argument there is out there, there's always this ridiculous conspiracy-based theory to counter it. So I'm going to take some time to get all the information together in a series of videos so I can make an informed decision. It's a bit of a daunting task to say the least, but I consider it an important part of my ongoing education into the field of horticulture and permaculture. And the best place to start is to understand exactly what it is we're talking about. So what is a GMO? Well, simply put, a GMO, or genetically modified organism, is the result of a laboratory process where genes from the DNA of a species is extracted and artificially forced into the genes of an unrelated animal or plant. These foreign genes can come from bacteria, viruses, insects, animals, or even humans. It does sound scary for anyone just starting out finding out all about it, and is one of the first reasons why so many people are against it. The fear of the unknown. But is there really anything we should actually be worried about? Well, a lot of people think so. So let's take an in-depth look at what actually happens in the laboratory to create a GMO. Now, to make a genetically modified organism, there are three components you require. First is the gene that you want to transfer. Then you need something to transfer it into, and that's called the target species. Then you need a vector to take that gene into the target species cell. Sounds simple enough, but it's actually quite complicated, because first you need to identify the gene, and then you need to cut it out and isolate it from the original organism. Now, these things are microscopic. You can't see them with the naked eye, so how the heck do they do that? Well, with the use of restrictive enzymes, this can be accomplished. Not easily, but it can be accomplished. Which brings up the next question. What is a restrictive enzyme? In simple terms, a restrictive endonuclease, or RE, is a biological pair of scissors. It's an enzyme, hence the word restrictive enzyme, that splices specific areas of a DNA. This area, or sequence, is only about 6 base pairs long, depending on what you want to do. And there are thousands of these REs, isolated mainly from bacteria, that use this incredible system to splice virus DNA. They use it as a very effective defense mechanism. The resulting spliced sequence is called a transgene. The next part is the spooky part, putting the transgene into the host genome. How do they do this? Well, the scientists, take a bacteria or a virus which is capable of getting into the host cell. But before they let it do its thing, they modify it. Told you, sounds spooky. It's simply a case of removing the portions of the virus's genome that causes harm and leaving the genes responsible for getting into the host cell. In other words, making that virus safe by extracting any of the bits that make it dangerous. This modified virus or bacteria is called the vector. Then they let the vector do its thing by getting into the cell and inserting the transgene into the host genome. After that, every time the gene is replicated and new cells are made, the transgene will be found in the DNA of every cell. Voila! So why do scientists go through all this trouble just to produce a new plant or animal? Is it because they want to play God? Is it for the shock value? Is it for total control, or just because they can? Well, yes, I'm sure some of it is just because they can, but the main driving force is to feed the world and try to save the planet at the same time. Whether you believe this or not, it is the reason that the scientists and the big corporations are giving to produce GMOs. Two big goals they are working towards is to produce crops that can survive in places where they wouldn't otherwise be able to, such as arid landscapes where many of the world's people are dying of starvation. The second is an environmental issue, and that is to A, produce crops that are resistant to pests, so no insecticides are needed, and B, to create crops that produce a greater yield in a smaller area, thereby reducing the need to expand agricultural land. And this is in relation to the many acres of rainforest that are cut down every day to make way for those agricultural landscapes. Well, that's the end of part 1 on this series of videos about the GMO controversy. I will be putting together a playlist so you can see them all there. Well, thank you for watching, and I hope you got a little bit out of it, and if you did, please give me a big thumbs up, and please subscribe to my channel. Every little bit counts, and your ongoing support is more than welcome. Until next time, thank you again, and remember, keep calm and garden on.